Hello everyone, this is Vipul Purohit and I welcome you back to the another segment of the chapter on solutions. In this particular session, as you can see, we are going to discuss about ideal as well as non-ideal solutions. So here we start. First of all, my dear friends, what is an ideal solution is? All those solutions that obeys Raoult's law of vapor pressure over the entire range of composition at all temperatures are known as ideal solutions. ओके राउल्स लॉ ऑफ वेपर प्रेशर क्या होता है वो मैंने पहले के वीडियोस में आपको ऑलरेडी समझाया हुआ है। यहाँ पर जितने भी कंपोजिशन है, जितने भी कॉन्स्टिट्यूएंट्स सोल्यूशन में, वो उसके एंटायर रेंज को हम कंसिडर करेंगे और सारे के सारे टेम्परेचर को हम कंसिडर करेंगे। एंड इन दिस कंडीशन अगर राउल्स लॉ ओबे होता है then we call that solution as a ideal solution. Now as usual we consider a binary solution made up of two components A as well as B. Now when we mix the two liquids A and B, then considering ideal solution, what are the essential characteristics are? First one is, जैसे मैंने आपको बताया, ideal solutions are those which obey Raoult's law over all temperature as well as pressure. दूसरा पॉइंट है कि इन सोल्यूशन में तीन प्रकार का इंटरैक्शन होता है। एक तो आपस में होता है और एक दूसरे के साथ होता है। अभी आपस में होता है उसको बोलते हैं इंट्रा और एक दूसरे के साथ होता है वो है इंटर। यानी इस तरीके से तीन प्रकार का इंटरैक्शन है। फर्स्ट वन इज विद इन हिमसेल्फ, दैट इज ए एंड ए. नेक्स्ट वन इज between the two different ones, that is A and B, and third once again within the same, that is B and B. So these are the three types of interactions. Now because we are very clear that this is going to obey Raoult's law at all temperatures, at all pressures, so these interactions are related to the partial pressures also, and because they are going to obey the Raoult's law, we say that these interactions have the same strength. Point number 3, the enthalpy of the solution remains constant. यानी इसका मतलब the total energy remains constant. अब constant का मतलब याद रखिएगा दोस्तों, value is not zero, the change is zero. Okay, this is very important my dear friends, you have to remember this word well. So if the change is given by delta, so H is the symbol of enthalpy, so the change in the enthalpy of the solution is zero. This is point number 3. We move to the next point now, and that is on mixing of the two liquids, the total volume also remains constant. And constant, once again, we know that the change is going to be zero. So delta V, V stands for volume. So delta V of mixing is equal to 0. The next point is whenever we talk about the activity, okay, so that means we talk about basically molality as well as activity coefficient, so that we get activity. So the activity of a particular component is always equal to the mole fraction. Now if I denote this activity as A of a particular component A, then it is equal to what? XA, where X is the mole fraction of A. Okay, so the activity of A is equal to the mole fraction of A. Now we move on to the next part, and that is non-ideal solution. Okay, if you understand the ideal solution, non-ideal solution is very easy. Okay, once again we consider a binary solution made up of A as well as B. So the first point is they are the solutions which does not obey Raoult's law. Okay, when I talk about ideal solution, they obey Raoult's law. Here we say we do not obey Raoult's law. Okay, and that means there is difference. So when you talk about the second point, that is there are three types of interactions, as I said, amongst the two and within themselves. So accordingly we have AA, AB as well as BB. Now here it is not going to obey Raoult's law. So obviously the strength between the AA as well as the AB and the BB are going to be different. So these interactions have different strength. In the previous case we said that the interactions had the same strength. Now it is different. We move on to the next point. Now on mixing, the enthalpy of the solution changes. It's not going to remain constant, my dear friends, because it's not going to obey the Raoults law. So there are going to be changes taking place. The change is given by delta, and when the change is going to take place, that means it has certain value. अगर हम ऐसा बोलते हैं कि चेंज का जो कंसेप्ट है तो सोल्यूशन यहाँ पर चेंज हो रहा है, ओके, मतलब चेंज का कोई वैल्यू होगा, और अगर कोई वैल्यू है तो इट इज नॉट इक्वल टू जीरो. सिमिलरली अगर एंथैल्पी में कोई चेंज नहीं हो रहा है तो सॉरी एंथैल्पी में चेंजेस हो रहा है तो ऑब्वियसली वॉल्यूम में भी चेंजेस होगा, तो इसलिए हम लिखेंगे डेल्टा वी इज ऑल्सो नॉट इक्वल टू जीरो. और जब हम एक्टिविटी की बात करते हैं तो वो मोल फ्रैक्शन के साथ उसका इक्वालिटी नहीं हो पाएगा, because simple reason is there is going to be the difference as compared to the Raoults law is concerned. So the activity of a particular component is not equal to the mole fraction, and Raoults law obviously considers the mole fraction. So we say activity of A is not equal to the mole fraction of A. So my dear friends, what I want to say is, if you understand the Raoults law very well, and then if you connect it with the different types of solutions, then it becomes very easy. So here in this particular session, we have spoken about ideal as well as non-ideal. उसमें भी आप ideal solutions को समझने की कोशिश कीजिए कि वो obey करेगा Raoults law. उसमें जो तीनों प्रकार के interactions हैं उनका strength same होगा, एंथैल्पी में कोई चेंज नहीं होगा, वॉल्यूम में कोई चेंज नहीं होगा, और जो उनकी एक्टिविटी रहेगी ऑफ अ पर्टिकुलर कंपोनेंट विल बी इक्वल टू द मोल फ्रैक्शन. ओके, ये 5 पॉइंट्स आपको याद रखना है व्हेन इट कम्स टू आइडियल सोल्यूशन. नॉन आइडियल सोल्यूशन को उसका ऑपोजिट कर दीजिए, यानी वो ओबे नहीं करेगा राउल्स लॉ. दूसरा कि ओबे नहीं करने का जैसे इंटरैक्शंस की स्ट्रेंथ अलग अलग होगी, ओके, एंथैल्पी में चेंजेस होगा तो वॉल्यूम में चेंजेस होगा, और वॉल्यूम में चेंजेस हुआ तो ऑब्वियसली एक्टिविटी जो है उसका मोल फ्रैक्शन के साथ सिमिलरिटी नहीं रहेगा, इट विल नॉट बी इक्वल टू एक्स ए. Okay, so in this way, my dear friends, we can have questions based on ideal solution, non-ideal solution, or we can have the question like differentiate or compare between ideal and non-ideal solution. I hope through this particular session you have understood this very well. Until we meet next time, do take good care of yourself. Thank you. Bye bye.